Good evening, ladies and gentlemen. Myself, Deep Kumar Shaha, Assistant Professor, Department of Mechatronics Engineering, Kuwait. Along with me, we have Irfan Ahmed Bhuiya and Lavanya Talukdar as moderator to provide any sort of technical support to this session. Today, we are in the second day of International Conference on Automation, Control, and Mechatronics for Industry 4.0. Current time is 6:30 p.m. Bangladesh Standard Time. Now, I would like to welcome all of you in the keynote session number 10 of ACMI 2021. On this special occasion, we feel honored to have Professor Dr. Mariofanna Milanova from University of Arkansas at Little Rock, United States of America as a keynote speaker. ACMI 2021 has got a new dimension to have a resourceful person like her. So dear audience, this is the time to welcome our honorable keynote speaker, Professor Dr. Mariofanna Milanova, with big round applause. Thank you for your appreciation. It's our immense pleasure to have Dr. MD Helal An Nahian from Khulna University of Engineering and Technology, Bangladesh as chair, and Dr. Shoumi Dotto from Institute of Engineering and Management, India as co-chair of this keynote session. After the end of the keynote presentation, there will be a Q&A session. All the audiences are requested to write question, if any, in the chat box. Audience can also ask live question in Zoom using raise hand option after the end of the presentation. Now, I would like to request our honorable chair and co-chair to take the floor and introduce our honorable keynote speaker to the audience. So, sir, the floor is yours, please.
Thank you, Deep Kumar. So, I'm audible. Can you hear me?
Yes, sir.
Okay, thank you. Yeah, this is the keynote session 10. So I would like to welcome Professor Dr. Mariofanna Milanova. So Professor, hello, Professor. It's a very good morning for you and good evening for us. So can you hear me? Yeah.
Okay.
So honorable keynote speaker and my colleagues and the honorable session co-chair, convener, moderators, and all the audience. Welcome you all to this keynote session 10. And I am here, I'm Dr. Mohammad Helal An Nahian, Associate Professor of Department of Mechanical Engineering, Kuwait, Khulna. So let me first give you the floor to introduce our session co-chair, Dr. Shoumi Dotto. Dr. Shoumi Dotto, can you hear us?
Yes. Very good afternoon, good evening to all of you. Very good morning to the conference organizer. So it is a very immense pleasure to connect with you all in this conference, that ACMI. Today we would like to show our gratitude to our keynote speaker, Dr. Mariofanna Milanova, University of Arkansas, and at Little Rock, USA. So the keynote title is Visual Intelligence and Deep Learning Models. What we can learn from hierarchies in primate visual cortex. So I would like to introduce our keynote speaker with the session first. So Mariofanna Milanova is a professor of the computer science department at University of Arkansas at Little Rock since 2001. She received a MSc in expert system and artificial intelligence and PhD in engineering and computer science from Technical University, Sofia, Bulgaria. Dr. Milanova conducted postdoctoral research in visual perception at the University at Paderborn, Germany. Dr. Milanova has extensive academic experience at various academic and research organizations worldwide. Dr. Milanova is IEEE senior member, Fulbright US Scholar, and NVIDIA Deep Learning Institute of University Ambassador. Dr. Milanova's work is supported by NFS, NIH, DARPA, DOD, Homeland Security, NATO, Nokia Bell Lab, NJ, USA, and Nokia Finland. She has published more than 120 publications, over 53 journals, 35 book chapters, and numerous conference papers, and has 2 patents also. So very warm welcome to Dr. Milanova. Please enlighten us with your knowledge and with your expertise areas. So over to you, ma'am.
Thank you so much for wonderful introduction, Dr. Dutta. Thank you so much. So it's my great pleasure to be here, and yeah, thank you for organizing this conference and your invitation. So I'm really excited to be here. Like I mentioned, I work already with several different countries, and I have students from everywhere, from Bangladesh, from India, from China, from everywhere. Actually, yeah, I have experience working in different countries. So maybe I should start with sharing my screen, what we do usually. Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Good, good. So what I want to say is, please don't worry, just stop me if you need it. If you have some questions, stop me. Maybe the title looks like more neuroscience and biology, but you can ask me any questions that you have, because I'm also NVIDIA Deep Learning Ambassador, and I'm giving workshops. If you want, we can schedule workshop. I will show you in the end. So it's something that is really very interesting and very useful for everybody. So what I will start again. The pronunciation of Arkansas is very strange. It's Arkansas, but we pronounce Arkansas. This is the place of my university. And I would like to invite all of you. I hope that in the future we can travel easier. I can visit
Professor
you.
Milanova, will you please make it full screen mode? Yeah, at the bottom right corner. Yeah.
Yeah, I know,
little
but it's
left,
kind of difficult. No, it becomes in 2 screens, and I don't
Ma'am, you can press F5 from your keyboard, then it will be in the screen, full screen mode also.
I know, but I cannot see you guys.
Oh, okay.
If you want me, I can do it, but I cannot see you. No, this become even worse. Well, I think that it's still okay. I think it's a maximum. It's becoming worse. I know. I'm giving talks almost. I mean, I have another after you guys. I'm so sorry, but really, I don't like to move it because it's complicated. Makes in 2 screens, and I cannot follow if you have a question. I really want to follow you if you have a questions and make it more interactive. I'm so sorry.
Yeah, okay, but, please carry on.
Yeah, thank you. Appreciate it. Because like I say, And we are not very big state, but we have beautiful nature. It's actually natural state. It's beautiful. I'm sure that you have probably friends already study here. So my talk is about the visual intelligence, and I put this image that we see every day with the traffic. And why visual intelligence is important is because 90% of information transmitted to the brain is actually visual, okay? So also, I will give you the presentation, and please go and take a look at the links. They are really very useful links. So while what we are doing our job in visual perceiving the environment, we actually usually pay attention. And most of my work and my students' work is about visual or audio attention. It's about where the attention goes. So the study is you know, kind of psychology, neuroscience, computer science. So many areas are included in our work. So I like this Moravec sentence that something that is easy for computer is very hard for human, and what is easy for human is hard for computer. So it's a kind of you know, kind of how we can actually work together, because main part of our work is actually human-machine interaction, okay? And even become more and more popular right now when we're doing constantly communicating with computers, interacting constantly. But interesting is also that 28% of the words in the web page were reading. So like I say, the visual representation and visual information is very, very important. And of course, you know that artificial intelligence becomes so popular in many, many areas. Obviously, is in control and manufacturing, energy, transport, and everywhere. So I have here some examples of how people and computers actually extract information. So some definitions about the segmentation. So there are different kinds of segmentation. When we do, for example, classification, we know that we want to classify objects. If we want to detect, we particularly detecting, there is a semantic segmentation that we can differentiate the objects, but there is another one that is instant segmentation, when we differentiate the objects but also count them, okay? So the main task, of course, it's can we create the algorithms that can see like a human seeing. So I have some examples here for medical applications, because we have actually here around 20 hospitals around our city. So obviously, it's important to study how human brain accept visual information. And like I say, it's not just for visual, it's also for audio information and any kind of signals. It's more general work, but in this talk, I will give you examples with visual intelligence. So what is the main concept is that what we perceive with our eyes, or what the camera can perceive, is this visible state. So we have a lot of from the word actually is mapped to this visible state, and our brain or the algorithms, they have to interpret the environment. And it's a study from Barlow, 1960, that we have a low-level visual representation, actually use primary knowledge and extract the redundancy of the environment. So we have obviously redundancy in this environment. So the small and simple model that was used, and if you are teaching, learning and study image processing, we extract information using variety of filters, okay? So this is the linear model that is combination from combining basic functions of filters and coefficients. But this is the linear model. These are the filters. In many years, like you remember, and you probably still use it, they are powerful techniques to extract features like SERV, SIF, histogram-oriented gradient, you know, so many principal component analysis, all of this feature extraction and region of interest detector, you know. So this was many years, and like I say, don't forget them, they are really good. So, but you probably are familiar with this diagram because it's so popular. Artificial intelligence is not new area, and I'm you know, happy to study, and I studied actually many years ago when it was not so popular. Fortunate to have a good teachers. And when in one moment artificial intelligence was kind of saying, oh, it's good for games, we start implementing in 1980 machine learning algorithms like support vector machine become popular and so on. But from 2010, as you know, deep learning is already everywhere, and I'm sure that you're working in this direction. So if you know, the differences, main differences that before, like I show you, you extract features kind of handmade, manually extracting or pre-processing, extracting features, and after that using some kind of regression classification algorithm to make a decision. So, but actually humans can make very good decision very quickly, and they can switch tasks. So what is the main idea of deep learning is that we're learning like a child. When you see many times one object, for example, this number 2, when this number 2 is showing us, we immediately recognize. So all of this is kind of, people like it so much because deep learning model can automatically kind of understanding what is inside of the environment and making a decision or inference. Okay, so this is the main difference, and I hope everybody already study deep learning, so I'm not spending much time. But you know that this picture is so famous that actually when we seeing one image in the beginning, we extract low-level features. They probably look like this, and I will show you why. Middle level of features, and after that, the high-level features that are more combined and reconstruct the image. So this is the very simple representation of only one model. Actually, you can have a fully connected neural network, okay? Or you can have it, what is also very popular, convolutional neural network. If you are in controls and theory and signal processing, I'm sure that you know what is the convolution, but if somebody has a question, I will present it. It's a kind of manipulation between two functions that build and modify them and create one new output. Okay, so we were actually minimizing the size of the output data. But like I say, if you have questions about convolution that I'm thinking that you know, some people don't know, for them is kind of strange. But another model, so on the base of architecture, neural architecture, we have several models. I will summarize that we have fully connected neural network. We can have, like I show you, convolutional. You can have, this is another model that is unsupervised. Previous models are supervised because we are showing a lot of images with labels, for example, numbers, digital numbers, and after that, in training and in testing, we test with a new image and making a decision. Another model is autoencoder. Autoencoder is completely unsupervised. So we extract features in encoder part from the image or whatever data set you have it. And after that, in decoding, we will reconstruct, okay? It's useful, for example, in this case, for segmentation. So, and another models that are class of neural networks that are recurrent neural networks. I have also examples here, and long short-term memory, okay? So going back to the brain, I'm not going to explain all of this, but the interesting part is my study actually was about how brain works and how we perceive the environment from retina cells and going to visual cortex cells. And as you can see here, even better, even that from the visual cortex, we receive the information in the brain, this information, one part is going to object recognition. So the object recognition is in one part of the brain, and motion perceiving movements is another part of the brain. So, but the study that the deep learning study, deep learning models are based initially of the study of Hubelt and Wessel in 1957. And I have the video here, but it's a long video. So how these simple visual cortex cells, they react on the bars of the light with spatial angle. Okay, so every neuron is activated when the light is coming with spatial angle. It's very interesting video if you want me to show you, but it's so long. So why my study is from 1998 and 2000, when the deep learning was not so popular, because we have a project actually. We didn't call it self-driving car, but we call it that we want to learn how people perceive the environment in Germany when actually was assembling cars and manufacturing. So the robot needs to interact with the objects in real time very quickly. So the retina, so this is why we study what kind of information we can extract and simulate. So for example, retina cells can be simulated with difference of Gaussian. and visual cortex cells that they react, I told you, in particular ages. So they are simulated with Gabor filters, but this was, like I say, before having this hardware to work with deep learning models. But if you are using, for example, I have example here of sparse coding. If you are using the sparse coding, this kind of spatial decomposition, you actually can simulate the primary visual cortex. Okay, and I'm giving here examples. So I encourage you, if you are not so familiar with the decomposition techniques, please study the decomposition techniques. They are so important for signal processing in general, and they are using unsupervised learning. They are implemented in several autoencoder, and right now there are new autoencoders that they can simulate better, extracting unsupervised the property of the environment. So the study that we did was with, like I mentioned, with sparse coding, but maybe this is kind of more biological for you. But the main idea of this decomposition, like I'm showing here, if you're using only part of the information, part of the information, this what we will see, So on some of the basic functions, I'm sure that some of you are using principal component analysis or independent component analysis, so it's the same concept. So you need all the components to see the clear image. So there are, I have several slides here about different deep learning models. Like I say, extracting features automatically because we are able to integrate different layers, in this case, we were showing convolutional neural network with the fully connected in the end layers and classes. So I'm showing also some popular like R region, convolutional region, regions, convolutional neural network, what job can do, similar of AlexNet. We're using many of them. We're using right now RCNN, Mascar CNN. As you can see, the differences are, for example, this one is going to do convolution in many areas, but another one that is a fast R CNN is doing convolution on the base of the whole image and find regions of interest, and after that going deeper to these regions to understand what is there, the classification of the object, and doing fully connected again to make a classification. Okay, so I don't have in this presentation, I think, the last studies that we do, but even in the beginning, when people decided to use this already deep learning model, they realize now that some of the tasks needs a little bit improvement of the models. So what I want to say, for example, this region proposal network is trying to find the area of interest. And I start my presentation with attention. This area of interest is actually attention. So this is why our research is mostly about models of attention. So when we start our project, we have a project with X-ray data. for medical applications, but also for looking in the baggage, what is inside of the baggage if you have, in airport. So when we start our study, we use existing models, but we realize that for our particular data set, or maybe everybody realized this, but this region proposal cannot detect the objects, because if you don't detect the objects, after that, the decision is wrong. So we replace this region proposal network with our model, okay? So there are families of convolutional, these are only convolutional neural networks, but like I say, don't think that all of this architecture automatically can be implemented for your task, okay? So think about this, because they are growing extremely fast. Say these are for segmentation, for example. For medical segmentation, we use, I'm trying my students, all of them, they are participating in Kaggle competitions, in a lot of startup company competition. So it's popular to use the data set that are available. So for segmentation particularly, we have this dice, what we call metrics that match what is the mask, because these algorithms that I show you until now, they are, most of them, they are, exception autoencoder, they are using labeled data. So you need to label the area of interest, like you see here, okay? So it's a label it with area of interest, training the model. And when the new image is coming, is possible, we measure how good is the segmentation, comparing the areas of the mask with the area, segmented area that we get like a result. So I'm working constantly on idea to, to compare, kind of comparing and what is in the machine artificial intelligence is what is in our brain, because this will help us to improve the deep learning models. As you can see, even from this image, okay, we have already deep learning, reinforcement learning, that is powerful, but it's not enough. The most difficult part is abstraction, and associations, okay? How we make associations, how we do abstractions, okay? So the study that is here, it's really very good to read it, because how expensive is to train the models, deep learning model. And I'm sure that you have this, we will have the same question about the hardware and about this statistics here, that deep learning training session 1 deep learning, and remember they are so big in natural language understanding, natural language processing or translation. They are using a lot of words and a lot of time to training, but one training session is equal to annual energy consumption of 125 Danish homes, because it's Danish Denmark study and is published here. So the question right now is optimize the deep learning architectures, because they are energy consuming, they are not cheap. So I will give you some solution of this, except that you have to, like it's your future, to think about implementing a new deep learning architecture, optimizing training process. So One of the aspects, like I start in the beginning, is attention, where the attention goes. And the study of Koch is one of the first studies from 2000 and a little bit before. And what we call is actually, we call bottom up. Why is bottom up? Because you don't have idea what is the task, where the people look at, in this image. But extracting several features, channels of features, this is also kind of layers of information that we extract, and combining, we will say that maybe here this white spot is the attention, maybe, but not only. Anyway, this is the bottom up because it's coming only information from the environment, from the image. But we have another, what we call top down, that it's related with what is the task. And this is why bottom up silence, we call it silency, because we can create this map from the information of the environment. But task-driven silence is attention when we already know what we're looking for. Okay, the task-driven silence. We use this attention, and I will show you several examples. This is more fun. It's not so theoretical. For example, we use it. And even now it's popular, and one of my patents is actually compressing data. And as you can see, this is the original, the left side, this side. It's original image. And when we're driving, we pay attention for particular objects. And this image here on the right side is actually the background, or the street is compressed 102 times. Okay, and as you can see, we're okay. We can live with this, and we will transmit this information. So we're using this approach for games, rendering quickly games when some ball is moving, for example, or for transmitting data. We're doing this, I mentioned that it's already patented. We're doing this, and we have this structure, even that was not called deep learning, but is called inverse pyramidal decomposition. So we have a coding part. We can stop the representation or compressing the data in any layer. You can see this is the layer configuration. It's a concept like autoencoder decoder. So because when we decompose the information, we actually create embedding layer or minimizing the dimensionality. And after that, decoder will recover the information. So we use it for medical application. This is one of them. For example, this application was with cell phone. If somebody is in area without close hospital, we can capture the image. I mean, some biting or some kind of problem on the skin. And to extract the particular area, if it's in hospital, they extract this area manually. But because in this case, obviously, it's not so difficult, because there is a obvious difference between the skin and features anyway, we capture where is the area of interest and automatically create the contour. Okay, this contour actually in this part, this is actually the region of interest, we can transmit quickly to the doctor. Instead of transmitting the whole image, we transmit just part of the area. And this concept we are using right now in our region of interest for X-ray images. So it's the same idea. The beauty of this is that you extract automatically the contour, and this contour you can use it for labeling the data. So there are many applications of automatically extracting area of interest, and this is done from attention. Okay, these are another attention models. Another attention model that we implement, it's very interesting study too. It's about babies that before 1 year, they're less than 1 year, but some babies die during the sleep. So the parents are worried, but this is empty. But the problem is the baby probably put face down or probably is covered with some object. So our study was from simple remote camera to capture images of the baby position, and extract the text, So it's a model that probably you know, and is very famous, is a see, attend, and tell model. That is seeing the image, and after that create the text or captioning the text. This is automatic captioning text. Baby sleeping on the tummy. So, and we send this text to the cell phone of the parents and inform them. So they are like alarm or something, but if everything is okay, we don't do this. So this is extension of a visual question answering system that we implement in hospital, but it can be implemented, for example, with game or whatever. It's a combining. In both cases, we combine, like I say, we work also with long short-term memory, natural language processing, plus images. Okay? So one big part of our work was also facial emotion understanding. We have a little time, and I'm almost done with examples. I just want to save time for questions. So this is the deep learning emotion recognition, as you can see, from different data sets. And it's the same concept like I showed you in the beginning. This is one of the first models, AlexNet, and the results from Alex. These people, these children, they are autistic, so they look strange. And for this kind of situation, when they don't express regular way emotions, it's kind of difficult to understand them. So we work with the hospital, understanding emotions of autistic kids. And this another study from Italy, my collaborators, they give us a lot of videos of depressed people. And this study becomes so popular. I have a student from India also working on depression and monitoring emotions. This can be integrated with voice. And the study here is a proof that our measurement correlate with the measurement, medical measurement. Okay? So we did a lot of security projects. This is recognizing faces for security. We did also project on, this is also very popular, deep fake, and creating fake videos, creating fake images. It's one of my students work in Facebook, and they did a study about this problem, and they asked us to investigate a little bit more. So what we did actually, we have a comparison between the emotions. So people can create fake faces or fake videos, but they are still not got so good with emotions. Okay, so movement of the eyes and so on. We have a comparison between real and fake. The attention can go also to particular areas like particular, see, this is the attention where it's going, and create a skeleton of the human body or skeleton of the face. You can do this, and we did this for Singapore. Okay, so for Singapore, the study was to prevent falling, not to detect falling. When person fall, I mean, it's their devices to inform people. But what we want, and the study is home for old people, and the study is to monitor the gait movements of people and to prevent falling. So we have a lot of algorithms here. The system looks like this. People are walking, and we monitoring the gait using the information from the skeleton, and monitoring gait every day for period of time. Actually, the study was at least 6 months period, and to see if there are improvement or the opposite. It's not moving very well, this person. Okay, and this is the statistics, and this data of gait. There are formulas in another my presentation how to actually calculate the performance. These data are integrated with different medical measurements, like a blood pressure or any medical condition. So it's a preventing fall. So I'm almost in the end of my presentation. So we know, everybody, that we're in for industrial revolution. You can see here the first one and second, third, and fourth. So the dream, I like this article, that actually the prediction is, I don't know if you agree or not, but artificial general intelligence will be available in 2040. This is not far away, I think, if you think it. But this means that the machines, they will reach our cognitive capabilities. So they will perform like a human. And after that, it's more strange, and some people reject it, 2060. So what will be when you have some kind of I will say creatures, robots, whatever, that we don't know how they will react. So it's a lot of responsibilities about you guys, us, developers, to control, how to develop all of this future intelligence. And my study continue in the sense of was mostly about cognitive science, neuroscience, and improvement of deep learning models. But recently I found that we don't pay so much attention about the property of the words. So we have to integrate all of this that we needed in the future. So there's still social aspect, legal aspect, ethical aspect. So many aspects need to be integrated. Like I say, we don't need ignorance, skepticism. We don't need it. Okay. And of course, I don't want, like I like this, the biggest challenge is not that the machine will take over, but that we become too much like them. So we have to keep our personality. Like I say, there are many, many, many aspects. So I will want to save a little time to encourage you guys to become, if you don't already have somebody from your universities, to become a NVIDIA ambassador, because there are so many advantages. I have another talk, I have to give it after this talk, for advantages about being ambassador. I can give you the link here, it's over there, show you if you want me to show you. They are providing kits, teaching kits. They are providing, can show you briefly if you want me to. I don't know how is the time, but they provide workshops. I can schedule with you workshop or show you what is there, or online learning. These are, again, my research, our research of my students on monitoring human behavior. Of course, I acknowledge my students with, we have currently 4 projects that we're working on, and support of this project and support of my current and already graduate students. Let me see if I can show you this, but in the meantime, please. So there is a procedure to become a certified NVIDIA instructor. Okay, so you become certified instructor, and you will be able to get this teaching kits. They ask me if they are, you don't need a GPU for this one. Just think how I get yesterday, so easy to do the video now. So these are the workshops. So you have a self-learning online courses. You have workshops. It was a very good video yesterday. I show very quickly. Go there. Anyway, if you have questions, I will. The workshops are the workshops are with theoretical part and with programming exercises. I just don't know. Last time I saw the video, but right now I cannot. Anyway, if you have questions, just let me know. Yeah.
Thank you very much, Professor Mariofanna Milanova, for the very nice and informative presentation. So I would like to give the floor to the audience. So if you have any questions or comments, so please.
I think that they definitely needs to become a developers of NVIDIA. NVIDIA provides all of these courses are using the NVIDIA server. They provide discounts. They provide a free access to the server. My students using Google Colab. So for example, you can download it, the exercises from NVIDIA teaching courses, and after that you can use it in Google Colab. But any questions that you have, okay, become an ambassador.
Yeah, Professor, we have a question from the audience.
Yeah.
So Mr. Masbah will ask you, how does auto encoder model work on low light images? So in the chat box.
Yeah, on the low light means that the image is not good quality. Or what?
So Mr. Masbah, can you hear us?
Yes, sir, I can hear you.
Yeah, please unmute yourself, and you can,
Yes,
you can continue.
Ma'am, I was asking that how does autoencoder model work on low light images, ma'am? Like we have a data set of low light images. Can we like generate or reconstruct image with like a bright image or colorful image with autoencoder model, or like variational autoencoder model?
What is the image? Color it, you say? Color it image?
Low light image.
Moonlight.
Low light. I mean dark, a little bit dark, and absence of
light
light.
Intensity is lower, Professor, I guess.
Yes, sir.
So means that it's not so good quality, or it's a quality good, but it's doesn't matter. I mean, I need to see the image, but variational autoencoder, if you ask me, we implement for X-ray images. And we implement for color. It's not doing good job, okay? So the autoencoder, it's very important really to capture the statistical properties, like I show you here, variety of possibility of decomposition, because they are doing the decomposition. But if you don't, they assume you can, I have an article here, the variational autoencoder is mapping to Gaussian distribution. And you don't need to be exactly mapped to Gaussian distribution if your environment is more complicated, or like you say, something is more strange, or maybe you don't have a quite separation. Maybe you don't have a separation of the objects. Maybe you don't have obvious background and obvious object. Yeah. So if you don't have this obvious separation, there is a techniques. I can send you the articles. I like them very much right now, and they are, it's good. The dynamic mode decomposition is a different decomposition technique. So you have to play with different decomposition techniques that are already available, like a libraries. So I'm not going to ask people to, to make coding from scratch, but using the library of different decomposition. So you have to figure out what kind of autoencoder will do better job for you. But if you want me, I can send you. These are the last one that I have, generative convolutional net for dynamic patterns. They are good for videos, but they are also good for patterns that are, for example, water, something that has a texture. I don't know exactly.
Sorry for interruption, Professor. I guess we are running out of time. So, so we have some formalities left. So is there any more comments from the quick comments or questions from the audience?
Yeah. Is there any query? Please, you can type in the chat box, or you can directly unmute and talk to us. Query?
Doesn't matter that it's light. Yes, I see.
Yeah.
They are, yeah. But they
so
will still get the component. Understand?
I have just one comment, like So far, I remember you have mentioned that baby's condition can be text to the parents. So is it real time? I guess so, right? Yes.
Yes.
So I would like to, I would be very happy to see this technology for the football field, like VAR technology nowadays. So it takes time for the referee to go back to the camera and see. So it will be better to implement this technology for the football match, and it can be, I mean, instantly feedback to the referee, right?
Look for the articles. There are articles already doing. Just Google it, question answering in game or football or whatever, soccer.
Yeah.
Question answering system. There are. I'm 100% sure.
Yeah. So thank you very much, Professor, for your very nice presentation and
you.
joining this conference. So now I would like to, so the convener, will you please finish the formalities? Mr.
Yes,
Deep
sir.
Kumar, can you hear me? Yeah,
Yes, sir.
please.
Yes, sir. Thank you, sir. Thank you, ma'am, for your excellent presentation. At this stage, I would like to request Honorable Session Chair, Dr. MD Helal Nahian, to hand over a certificate to our keynote speaker, Professor Dr. Mariofanna Milanova, as a token of appreciation.
Well, thank you, Professor Dr. Mariofanna Milanova, for joining with us. This is a token of gratitude from our side.
Thank you so much. Oh yeah, it looks so good. It's very beautiful.
Thank you, ma'am, for your wonderful presentation.
Thank you.
Thank you
If
for
you
connecting
have
us.
questions, yeah, keep in touch, okay?
Yeah, I guess Mr. Deep Kumar will send it to your mail, okay?
Yes, 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 definitely.
Yeah,
thank you very much.
You. I'm sorry that I have to leave. I have to go to another talk.
Okay, ma'am. Okay, ma'am.
Yeah, we are almost finished.
I request the host to take a group photo before ma'am leaves.
We have formalities like that, madam. I am continuing. Thank you, sir. Now it is time to appreciate our honorable session chair and co-chair. I, on behalf of organizing committee, would like to share certificates to our respected session chair, Dr. MD Helal Nahian, and session co-chair, Dr. Shomi Dotto, as a token of appreciation. Please
thank you very much,
sir, digitally.
So please take a group photo, okay?
Yes. Ladies and gentlemen, it's the time to capture this beautiful moment as a source of inspiration for next edition of the conference. I would like to request all of you to open your camera to complete the photo session and be a part of this beautiful memory. Please.
Thank you.
Irfan, can you hear me?
Yes, sir.
Please take the photo.
Yes.
Are you done?
Yes, sir, I'm done.
Okay.
Yeah,
Thanks
thank you very much. Thank you all
for your participation in the keynote session and make this session live. Our next session is closing ceremony that will be started from 7:30 p.m. Bangladesh Standard Time. I'd like to request all of you to attend the closing ceremony. Now, with the permission of session chair, I'd like to close this session. Thank you again.
Yeah, thank you. Thank you. Please.
Oh, thank you.
Thank you,
Thank you, all of you. Thank you, organizers, for this nice arrangement. Thank you. Thank you, all of you.
Thank you. That's very good.
Thank you. See you again. Thank you.
Yeah, see you.